Welcome everyone to Robot Builders Night Virtual for September 17th, 2024. We'll have the usual agenda of we have a queue going with Scott and Paul in it, and anyone else that has something that they'd like to talk about, and then we'll throw it open for open mic. So with that said, does anyone else besides Scott and Paul have anything to report or update us on for the queue? Oh, okay. Scott, you're up.
Yeah. Well, I just wanted to give a teaser about my presentation coming up. Not this Saturday, apparently, but next Saturday. So it'll have another week's worth of polish on it.
The 28th.
But you know, always remember you can't polish a turd. So, so anyway, I'm going to be talking mostly about a Visual Studio plugin that I use for cross compilation and embedded development, Pi development. I really like this tool. It's quite versatile. Has a lot of they even have like a local compiler for Pi, so you don't have to cross compile on the Pi. You can actually do it on your machine, and when you get a really big project, it helps with the compilation time. So I'm going to be kind of previewing that, mostly kind of towards an embedded C development process where and using JTAG hardware as well. A little bit of background on JTAGs. You know, a lot of people have worked with them quite a bit. Some people haven't. So I think that was where the origins of this presentation came from, is a desire for some of the guys to know more about that. So that's kind of what it's going to be covering. But I wanted to give you a heads up as far as the tools that are going to be used in case you want to, you know, install them. And I'm trying to drop this in the chat, but it didn't work out. Hang on a second. So in case you want to install the tools, of course, Visual Studio's community or code is free. And it's a very powerful IDE. I love their editor and their IntelliSense and all of that. It's one of the best IDEs I've ever used. And this plugin is also makes it even more powerful on doing embedded work and cross compilation, basically, which is really that when you're developing a program in Visual Studios, right, you're developing it and you're compiling it for Windows platform. Well, this tool allows you to compile it for an ARM part or a PIC or a Raspberry Pi. So I just dropped in kind of one of the text from one of the slides. I don't know if the links worked or not.
They didn't come through as links, no. But I'll tell you what, if you want to email them to me, Scott, I have your talk description that you sent me a few weeks back. And if you want to send me also a list of things that people would need if they wanted to try it during the talk, I can put that in the meeting announcement, and Doug can put it on the web page.
All right, yeah. I'll get it to you. I have to leave tomorrow on a business trip, so I'll get it to you sometime before the end of the weekend, and you can get it posted.
Great, thank you.
So that's just kind of a teaser of what the presentation is going to be. It depends on, a lot of it's just going to be demo and discussion and question and answer. So it's not a real lengthy, you know, PowerPoint. I think there's 10 or 12 slides in it now. There may be another handful by the final result, but it's not going to be a lot of just listening to me yamble on. I was going to show some of my code. This robot here I call Yar. for yet another robot. Uses ST 32 chip. So I'm going to be kind of using that as an example, showing you my implementation of their HAL code, which is their hardware abstraction layer. You know, that I used the NXP chips for a long time, you know, both the Cortex and the ARM7s and ARM9s. I used them a lot at work, and then I started working with the STs. I really like, there's a lot of power involved. Like this is an H7 part here. And it's, you know, it's like 480 megahertz. So it's got plenty of power, lots of pins. And the peripherals are very flexible. Like the timers, you can do almost anything you want to with the timers. So like I said, I'm just going to demo what I've done here, do some debugging, you know, scenarios, if you will. So that's just kind of a teaser about what's coming up in a week and a half.
Hey, Scott, what JTAG thing are you going to use? Are you going to use one from STM, or are you going to use a specific, you know, one of the Sigroks or something like that?
Yeah, well, that's one of the slides in the presentation. This particular board is one of their development boards, so their what they call ST Link is actually built into it.
Yeah, yeah, okay.
But unfortunately, this particular board, the robot was going backwards uncontrollably, and it ripped off the USB connector for the ST Link. So I'll actually be using an actual ST Link on here. It's one of the ST Link V2s. You can Google them. They're really cheap. They're like between 10 and 20 bucks.
Yeah, hold on a second. I want to ask you if, let's see, I think I've got something here.
But to just carry on that thought, a bunch of different, you know, I think like Spark Fun made a USB JTAG that does ARM. And I kind of talk about that in the presentation. There's what they call an open OCD interface. So as long as the JTAG supports that interface and the IDE supports that interface, then you can use whatever JTAG you want.
Okay.
And that's one of the things I talk about in the presentation is kind of those differences and where you might go wrong, because some JTAG, even though you may have like an open OCD, some JTAGs may not support that, and they only work with certain tools, or they only work with certain chips, like the ST Link, right? They only work with ST. But that's all part of the discussion and the presentation.
Yeah, I just want to know, is this is an ST Link here?
I can't see it well enough, but yeah, they make USB ST Link. Yeah. Yeah, that's.
It's not very expensive.
No, they range from about 10 bucks to 30 bucks.
Yeah,
So.
I just want to, because I like to follow along if I can.
Well, that'll be in the document that Paul will post probably early next week.
Okay, great.
Yeah, great. I've got a kind of a conceptual question, Scott, and maybe I shouldn't ask this here. Maybe I should wait for the talk. But what I'm wondering is, so I've never actually used JTAG debugging. I'm interested in how you would do it, but in a microcontroller environment, I can understand how you would get a JTAG controller that could stop the clock and adjust memory to put a breakpoint in at a memory address or stuff like that, or even have a hardware breakpoint that it could trip. But you mentioned you can use it with a Raspberry Pi running Linux, and that sort of blew my mind, because you got all these processes and the kernel, and how do you attach to what? It's not like you can like set a breakpoint in a memory address, or you got virtual memories. Is that like too difficult a question to hear?
That's part of the discussion,
Okay.
but just as a teaser, you don't use the JTAG hardware. Basically, you open up an SSH socket, and then within the Linux environment, the debugger is GDB, and that's built into Linux. So, but it's not really kernel aware so much as application aware, because what you do is you use the SSH socket to attach to a process, and then it can manipulate the process.
Okay.
Now,
Yeah,
in an embedded environment where you have a JTAG, you get a much deeper level of access. You know, the hardware registers and the peripheral registers, and the clock registers and all that. So you get a deeper level of access. But from a development perspective, a lot of times, especially like with the Linux platform where you're relying on the kernel to provide all the hardware resources, you don't need that kind of access, right? Because that's already done. You're dealing at a different layer now.
Thank you. Okay. Any questions for Scott? If not, let's see. I was next. I got a few things to show that I'm very excited about. One, I don't know if you can see it. Printing away over here is my brand new 3D printer that I got from Doug that had a lot of fun assembling, and it's printing just great. It's the cheapest 3D printer you can get. One that he talked about during his and John's 3D printing talk, and so what I have done so far is so I this is a modified version of a bumper assembly that I designed in Onshape, and so I printed it out, and here it is. Let's see. Get back to. So it's got two pieces that bolt together, forming a frame that holds the microswitch, and it actually seems to work decently well. Spring pushes back on the bumper. It does have a weakness that it flexes too much in the middle, so I've redesigned the bumper to give it some stiffening, but very excited about that because now I can sense stuff sense cones and
looking good, Paul.
So anyway, the micro switch clicks. So anyway, that's my bumper. So that's exciting.
Hey, Paul, if you don't want to reprint the whole thing, one of the things you could do is make an additional part to just bridge over that middle part and giving it some strength.
Yeah, that's what I did. The bumper was comprised of two parts that are bolted together, and so I just printed a third. I'm printing 3 up of the new one because there were some other issues as well, and I just put it backwards on to bridge across this, so it gives it a nice strong bridge. It's got a U-shaped profile. A bit hard to see that here, but it does. Anyway, So yeah, very excited about that. Have a question for the knowers of 3D printers. Is there anything you need to worry about keeping the 3D keeping the filament dry? I was like seeing something on the web about you should keep it dry, and then tonight I kicked off a print, and the filament was just broken. I don't know when it broke, but it was broken. Any tips on?
So that happens.
You're doing
If you, especially if you leave it like stressed, it'll break PLA well. If you like have it bent at an angle for, I don't know, it happens to me if I leave it like in the printer for 3 or 4 days at a time. Or if I, leave it out of the spool, like somehow, straightened out or something, because it naturally wants to be wound around the spool. But yeah, you want to keep it fairly dry. Like I don't have that problem in Colorado because it's so dry here anyway, but maybe where you are it's humid, so could be an issue.
So
Yeah.
you take the spool off when you're done with a print and put it in a plastic bag with some desiccant or something?
Yeah, that's what I typically do.
Oh, okay.
Yeah, put it back in the box. It should have come with the silica. They put it back in the box with silica. It should be fine. But yeah, my PLA does the same thing, Paul. Actually, I found that some colors don't do it and other colors do it. So it's hit and miss.
Cool.
Yeah.
Cool.
Yeah, Paul.
Yeah, mine does that as well.
If I've got a
Kind of
new
a pain in the
spool,
butt.
I just leave. I never take it off. I leave it on there. I never dry it. PLA is very forgiving. Now, if you're doing one of the higher temperature ones, then you probably should keep it dry. But
No, I'm just using PLA. What's in the white bucket, Mike?
I just
Well,
keep
it is-
mine in a Home Depot bucket with desiccant in it.
Smart.
That's a big bucket of desiccant.
Oh, well, there's desiccant and then lots of spools in here. There's
Okay.
some desiccant and then lots of spools.
if I'm not using a specific color or anything, I do put it in a plastic bag with desiccant. But if I'm using it, and I usually use one, since I'm lazy, I use it until it's gone. And so, that's why I have pink whatever's, and then I have yellow whatever's, and whatever's going on. But I don't treat PLA very, anything special. But it is brittle. So if you have a kink in it, it will break there.
I was doing what Ed said I shouldn't do, which was having it run straight down from the spool and then make a sharp angle into the feeder. So that's probably what I did wrong.
Yep, that happens to me too. So
Okay. Well, thanks for the tips, guys.
yeah, one other tip. There you can Google it online. There's certain types of cat litter that make very good desiccant, and it's really cheap.
Certain types of what?
Cat litter.
Yeah,
Oh,
unused.
okay.
I'm assuming. I mean, unused.
Yeah, unused.
All right. Thanks. And then I have one other thing I'm excited about. I got myself a new toy.
Whoa,
Ooh.
whoa, trucks. Wow.
Ooh.
This is the chassis kit. So it's
All right.
so
So fancy.
take the page out of Mike's book. I'm like, okay, get the platform, and then I can put the robot stuff on it. So this is the kit that's a bit cheaper than the thing with the body on it, because I don't need the body. So anyway, I'm gonna start assembling that here pretty in this week hopefully, and try and have 2 platforms ready for Robo Columbus.
Yep, that's cool. That's really cool. Isn't that's the same one Mike has, right?
No, Mike got the 1/5 or 1/6 scale.
Oh,
This
okay,
is at a
well,
1/10 scale.
yeah, okay, I got you. That's right.
Yeah.
That's a really
John
good
had a
one.
1/10, has a 1/10.
Does
John,
I have
John
yeah.
in
I
Canada.
have,
Yeah.
but not a track.
yeah, but he's got a 6-wheel 1/10 scale. This is just a 4-wheel. And do you guys know? Because like several of us have talked about trying to do Robo Magellan. Do you have to go climb over curbs in Robo Magellan? Does anyone know?
Mine can do it.
I know yours can. They told me in the store that this one can.
I don't remember that being in their rule set, but I wouldn't be surprised if they routed it over a curve. You know what I mean? But I want to say the run that Bob did last year, he never left grass,
Oh, okay.
you know.
Okay.
But you know, it's up to where they put it and what they do. You know, I mean, I'm sure it's different every year.
Okay. All right. That's all I had. Did anyone else have anything to want to talk about, report?
What was the printer, Paul? Was that an Ender?
It's the Ender 3 V2.
Mhm.
It's the $130 one.
Yeah, that's what I have.
Doug, that's what you have?
That's what I have. It's great.
Yeah, it's
a
working
workhorse.
great.
Yeah, yeah.
What?
It's a workhorse.
Yeah, I mean, it wasn't difficult to get the bed leveled, and once I got it leveled, it did all the test prints of one layer to make sure it was squishing the plastic down like it should. It just like prints beautifully and just like they show in the pictures, and comes out with a nice clean finish. It's nice.
Yep. Yeah, good printer. Nice.
So very, very happy and excited. I've got more than $130 worth of fun out of it so far, just assembling the thing, and I've got a useful bumper that, for the most part, works. Needs a little tweaking, but so much better than fighting with like erector set material and acrylic and all this nonsense that I had been doing. So thank you guys for showing me the way. Yes, Mickey Dean, $130 US for the whole thing. I can't believe it's so cheap. From
One thing you got to be careful about now, since you're going to be outdoors, and I don't think it'll be a problem in November, but you definitely don't want to take your car, put it in your car. To give you an idea, when I had, when we did that presentation last time, I actually had some parts made out of PLA, and I just threw them in the car and drove home. And so it was probably in the 90s. And when I got home, some of the parts were deformed. So you got to be careful about that.
Yeah, I figured what I'd do, Doug, is once I'm happy with the design, then I'll take it down to the library, and they've got a printer that'll do ABS. And so
that's the way to go. Yeah. Yeah. I think that's a great idea, because PLA is, of all the filaments, it's the easiest to print. So it's fun to use. I mean, like you say, you can get away with some weird things, like, you can have 2 posts and with a bridge of, like a 2 centimeters, and you can actually bridge across it. I mean, it's just things that you couldn't even think about doing in other filaments.
yeah, I was really kind of surprised that it printed these fairly large, they're like 1/2-inch holes, or 9/16, actually 14 millimeter holes, and didn't need support or anything for them, and they just printed fine. I was like, anyway, that's pretty neat.
Yep.
Okay. Let's see, if we don't have anyone else in the queue, let's throw it open for open mic, general discussion, whatever.
I just sent you an email, Paul. I went ahead and finished up the document while y'all were talking. I can't seem to include it in the chat. It won't take files, so.
Yeah,
have
just
that.
came through, Scott. Got it. Perfect. Thank you. We'll get that in the email and the website announcement. Yeah, I'm excited to hear how this stuff works because I've never used that. So what else has been going on, guys?
I've also been working on a BeagleBone AI platform. They have it's more powerful than the Jetson Nanos. And it actually has a microcontroller, an M0 microcontroller built into it. So you can actually offload real-time tasks like PWM, encoder interfaces, and basically it's a shared memory region with Linux. So you can actually access the registers in the microcontroller from Linux. So I've been playing around with that. The documentation's a little thin, so it's taken a little bit of time, but I really like that platform. It's really powerful. You know, I did the other robot with one of their other boards, BeagleBone Blue, which basically has, you know, a robot controller built onto it. It's got eight bridges already built into it and Wi-Fi and the whole thing. So really was impressed the way that came together. And, you know, there wasn't a lot of documentation on it, but what was there, you just plugged it in and it worked. So hopefully that'll be my next Robo Columbus controller. I'm thinking about using that on the platform that I got from the surplus platforms we got from, I'm drawing a blank on his name now, but so I bought one of those platforms from him. He was just using it on the contest earlier this year.
Oh, Kareem?
Kareem, yeah, thank you.
Yeah, yeah. That what do they call him? AT3 or something?
Yeah, really nicely built chassis. Yeah. So hopefully I'll have that put together, and that's also a native AI platform. So the idea is to do the object recognition off of it, because it's got plenty of horsepower in it, supposedly. I hadn't got there yet, so.
Man, I'm hearing that everyone's going to have an AI camera or a camera hooked up to AI for finding the cones this time round.
Well, it's one thing to say it, it's one thing to do it, right? It's a whole nother ball game. So I kind of gave up on the Oak D Lite that I had. I just couldn't get their drivers to work with my C code. I fought it and fought it and fought it and just never did make it work. And then I found the BeagleBone board and thought this is a better way to go anyway. Because I mean, you can natively run a OpenCV and do anything else with it you really want.
It sort of worries me that you were unsuccessful getting the Oak D Lite to work, because I'm hoping to make that thing work. And I think someone last week got it working. It might have been Harold, but I'm not sure about that.
Well, I think Doug had it working with the Python, and I had it working through Python examples. but it was importing their drivers and everything that came with it into my project was where it really, because they did a lot of the boost drivers, which was a whole nother library that I hadn't included. So all the install paths got broken, and I could have, maybe it could have been successful, but I reached my fuck it level and just gave up. Went on to something else, the next shiny object. So
Yeah, there's plenty of those.
yeah,
Yeah, I'm really been I've been communicating with Pat on this MaixSense A010, and it looks like a really nice sensor. The nice thing about it is, you know how you get some of these and they say, okay, here you go, 5 million pixels, da 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 da, da, and you're going like, shit, how am I gonna handle that? Well, with this one, you got 25 by 25, which is a really nice size. That's something you can wrap your hand around and manipulate. So, like I say, so far it's been pretty good. We found a few things, like for example, even though it's quotes 25 by 25, it seems like the edge of the sensor is a little flaky. So what I found was you need to take a 22 by 22, and that works. That then you can point it at a wall, and where you would expect all of the readings to be the same or close, it'll be the same or close. So anyway, a few little gotchas, but so far so good. I mean, this might be a just what I would call a little non-bumper for me,
So is this like a time of flight sensor?
Yeah, it's a time of flight. They're about I want to say $32. And they have a nice little display on the back so you can kind of see what's going on. Very easy. It is Python, though I'm sure you could do it in C++ or C, but they make it easy to do it in Python. So yeah. So I mean, and since I'm not a Python whiz, if I can do it in Python, you can do it in Python. Because like I say, that's not my strong point. So anyway, yeah, and supposedly, I haven't tried this out yet. It also apparently can be, instead of having like a Raspberry Pi, it can actually run off of a max bit, which, if you remember, was a something.
One of the Kendrite.
Yeah. What is it? Can try something?
Yeah, 210.
210.
Yeah.
Yeah. So apparently it'll work with that, but I haven't tried that yet. So
are you just hooking it up to a Raspberry Pi, or I guess?
Yeah, right now I'm just using the serial port. It does come with. Excuse me. I am using the USB port. There is a serial port access to it, so you can get the serial port. So it makes sense that you should use anything that can read a serial port.
Mm-hmm.
I mean, so
yeah, I actually hooked it up to an OpenMVH7 and got it to display the image on the LCD of the back of the camera. But in 25 by 25, it's a small portion of that display. It looks pretty hard to see.
Yeah.
So,
but I mean, is it the end all?
You go beyond that?
No, I don't think so. But I think if you want one that's, like I say, is not too small, like one of the like for example, Scott, you've got those time of flight sensors, but they're basically like kind of like a spot, and this one gives you a pretty good depth of field. So
Yeah, typically the spade array is like 38 degrees.
Yeah.
Yeah, the ones I was using on belts last year, I don't know how they do it. I don't know if it's optically or internally, but yeah, it's 3 degrees, which I found is quite helpful in a lot of scenarios, especially like when you're looking for big bushes and, you know, a real narrow chair leg or something, you know, would be difficult. But for the outdoor obstacle avoidance, it seemed to work really well.
Yeah, well, I'm going to have some. My plans are to use some of those this year. So, because I like them because of the range, they got really good range.
Yeah.
This MaixSense only has a range of, I think the max is 2.5 meters.
Yeah.
And what is really, what I think, I haven't done this testing, but I think with the 25-25, you might be able to do things like pick up a chain link fence. Okay. You know, you would see like a pattern in the data, which could be interesting. I haven't pointed it at a chain link, but it's gonna happen later. Another use would be a bush. You know how we have a lot of when we go up to Steve's, there's a lot of bushes that don't have any leaves on them, and their density is not super good. And you could see that with Ray, and Ray kept, you know, he would actually kind of like dig himself into it before he actually sensed it, and, you know, didn't have it. At that point, he was, you know, he's surrounded. I don't know. I'm thinking that this might be good for that kind of wispy grass and that in the leafless.
The Texas thicket.
Yeah, we'll just see how it goes.
Well, there's a fine line between it being sensitive enough and being too sensitive.
Right.
Because I mean, you don't really need to detect a blade of grass as long as you can run over it, right?
Right.
And that's one thing I've really struggled with, and you know, all the revisions of burp through the years is what kind of sensors work best. You know, what's reliable, and then what gives you information that you can actually reliably react to. Right?
Yeah.
Because like sonar, when I had it on there, you know, you had these huge overlaying cones. So you couldn't really say, all you knew was, well, somewhere over there is something, right? You couldn't really, and all you could do was turn to try to avoid it. And then, you know, you got to the time of flights and they got a smaller cone. So, and now I've gone from the 38-degree cone, which I still use on turd, because that's what it has on is just time of flight, some ST part. And like I said, they're 38 degrees. And the other ones I've been using now from, I forget what the company is that makes those. But they're 3 degrees. So I found that to be much more helpful for avoiding big things, like I said.
Yeah.
What do you guys think about the comparison between like the ST 8x8 sensor and this MaixSense sensor in terms of specs or any experience you have with them?
Makes sense. You mean the MaixSense?
Yeah.
Oh.
Yeah, the A010.
Mike could tell you about the ST ones. He's done a great job.
Right. I'm wondering if any of you other guys have either experienced or looked at the specs to have some perspective on how they compare to each other.
I didn't think the 8x8 sensor was good outside, is it?
Well, one of the things you got to watch out for in the time of flight sensors is the different sensors have what it's called a spade array, single photon something diode.
Avalanche detector.
And normally there's a grid of those. So even in a single time of flight sensor, there can be a grid of these spade arrays. like the one that I've worked with at work is 16 by 16. And so you can actually move the region of interest around within that 16 by 16 grid, right? And so the entire grid has a 38-degree cone of sensing area. But what you end up getting out of that, those 64 data points, is a single reading of a distance. And what they do, and because each one of these spade arrays is pointed in a slightly different direction, in our testing, it seemed like it was a little bit of a concave type of arrangement where each individual spade in that array was angled slightly different. And that's what gave you the 38-degree cone. And what they would do is average out those readings and give you that single distance. So if you had, like, for instance, a 38-degree cone within, I think it was 4 feet, is going to be somewhere around 12-inch diameter. So if you had a single point in that 12-inch diameter that, say, it was 20 inches away, you're going to get a reading somewhat less than that because it's going to average everything out. So I think the later version or later families of the time of flights, where it sounds like what Doug's using, is actually 25 individual time of flight sensors with their own spade array of some grid.
Right, and Mike used one that is 64 sensors, 8 by 8. And so
he's using an ST one.
Right.
Yeah.
ST.
Right.
Mhm.
Yeah, I forget what the family is. That's what I'm familiar with using at work.
Mhm.
And that's what I've used on Turd too, as a sensor array. But again, you have to understand that you're getting an average of that entire field. So if you're right on the edge of something, like hitting something, and half of your field of view is hitting it and half of it's not, you're going to get some reading that's past that. So you can't really just say, oh, there's an obstacle a foot in front of me, right? Because you may actually have an obstacle 6 inches in front of you and then no obstacle for the rest of your field.
yeah, but
So it's going to average those readings out.
But you're talking about essentially what produces one reading, and what Mike used was the VL53L8CX that gives you 64 readings.
Right, and that's what I'm saying is the later family ones, you can get individual data points out of that grid instead of it having the device itself average it out for you. But then, and I don't know how you handled that, Mike, but so then you're literally, it's like evaluating a picture, right? Because now you're having to evaluate per pixel or per sensor.
Right.
Say, okay, well, where is my object and how close is it?
Right, and that seems comparable to this 25 by 25 MaixSense device, and so the questions that come to mind when one thinks which of these would be a better cone detector / obstacle detector are, what are their ranges, their especially in outdoor sunlight, and maybe how quickly they respond. That's less of an issue probably, but range probably, and sensitivity to ambient light.
Yep, those will all be important for sure.
Yeah. So basically, I got a different version for my outdoor one. It's the VLC 53L8, and it claims to work better with ambient light, has improved performance in ambient light, and I haven't tested it out, but I figured the other one worked really good indoors, but outdoors I never tested it, so I decided to get a sensor for the outdoor one.
Yeah, I didn't have any trouble with them outdoors. We actually did testing at work because we're putting these things on elevators. And of course, sometimes you may have, a glass hatch or, sunlight coming in. So we did some light analysis on them and really didn't see any degradation. We're using like it's that same VX53 series from ST, but it's like the X1 version. So it's pretty much the entry level part. And like I said, it's 16 by 16 spade array, but we get a single reading out of it. Yeah, the VL53, they have like the L1s and L2s and L4s and
Right, with single reading. Yeah.
right.
Yeah, so this one basically says it has improved performance in ambient light. I don't have any data on it, but I guess I'm gonna have to try it out.
Yep.
Yeah, the board's a little bigger than the other board, so I'm not sure exactly what's different, but seems like the specs are the same except for that particular claim that it's better.
Well, they actually make a lens too. It's rather opaque, but it's the wavelength of light is set for the time of flight. So basically the only light that gets through that lens is of that wavelength that it's looking
That's
for.
interesting. Huh.
Yeah,
Wonder how would you get those lenses?
I don't remember where they came from. There were a lot of stuff we were testing. Oh, here we go. Yeah, see there are these little cap looking things. But like I said, you can't see through them. And that's what what actually ST recommends. One of their app notes, if you can see that really well. But and like I said, you can't really see through them. And according to ST, they only allow whatever the frequency of light is that the time of flight is using. But the interesting thing is our design has a clear lens, and we were testing these because we have a lot of disturbances, like with echoes from hardware. We're actually mounting these on like the door of an elevator. And so as the door is moving forward and back, we're measuring the distance between like a set point, a flag, if you will. And so we're basically determining that the doors are opening and closing and what speed they're at. So you imagine there's a lot of hardware and linkage and bolt heads and whatnot. So we have all kinds of problems with reflections from edges of stuff that we're seeing. And that's where that average it comes in at of that spade array. So one of the things that, that for the future improvements of the product is going to one like Mike's talking about, where you have multiple, you can actually narrow down the reading. It's more granular. So you can say, oh, well, the majority of this is this distance, and I'm going to avoid this other data that doesn't make sense to me.
When you read the data sheet carefully, it basically says, hey, you can sort of trust the outer perimeter of sensors, but verify. Yeah.
Yeah. So this is just to show you, this is the device that we have on elevators. Of course, it goes in an enclosure, but the time of flight is right there on the end. And like I said, it's one of those 5300 L1 series. So yeah, it's just an average of the entire reading.
Yeah. Now, I was thinking of using the by 8s on the front. I was going to put an array of 3 of these, so I've got 120 or 30 degree vision, and then use the by ones on the corners, so that like on the back and everything for really rough, okay, something's there. But in the front, I want to know what's there, if the cone's there, how close it is, if it's centered or not. And these work really good for that. At least I did for my indoor robot. Yeah.
Well, the thing you got to watch out for that I've run into that you don't have in the indoor is, like Paul was saying, blades of grass and clumps of grass, right? So because you think about the floor being a flat surface, and now you get out out in that yard, and I mean there's divots, and there's bare spots, clumps of grass. You got the stray blade of grass, and that's where that averaging out and having more granularity of being able to say, well, how far is my closest object, how far is the furthest object, that sort of thing. So it complicates software, but can definitely keep you from false triggers.
Yeah, haven't tried it yet.
That seems to be the real trick, is not necessarily being able to avoid things, but knowing when you don't have to avoid something.
Right. Like on these, you can sort of say, oh, I know that the lower sensors see the ground, so you got to ignore those. And then the upper sensors you can use for obstacles. You
may not want to ignore that exactly, because if you come up to a ledge, you don't want to drive off, right?
That's true. If there's nothing there, then it's crazy. But usually it's just noise and it's there. But you're right. If there's nothing there, then that's information. Yeah.
Right.
Yeah.
Yeah. That whole question of detecting negative profiles is kind of a tricky one. When we were doing the self-driving trucks, if we didn't have the full Velodyne, point cloud hardware on the truck, we said we don't support negative obstacles, is what they call them, as opposed to positive, where it's above ground and you run into it versus falling into it.
Right.
Well, I have a friend of mine works for one of the robotic companies, and they do like the robots you see at restaurants where they deliver your food to you. It's much bigger in Asia. But they had an instance where, now this is a 100-odd-pound robot, right, with a food tray on it, ended up driving down a stairwell because it couldn't recognize the fact that it was driving off of a cliff, basically. And of course, you think of that, if you're at the bottom of that stairwell, you may not come out of that battle too easily. So yeah, they were scrambling, trying to figure out how they can make this robot, because they're looking at it, well, it's just driving around on the floor, and no one ever thought, and you're talking about millions of dollars of development into this robot, and no one ever thought, well, it could drive down a set of stairs.
Well, my super old Roomba can detect the stairs.
Yeah, there's a downward-facing obstacle detector.
Yeah.
Yeah, cliff sensor.
Yeah, but in addition to these on the front of the bumper, I was going to also have a rotating LiDAR for general obstacle detection that won't see the ground clutter and stuff. So it can basically see where trees are and things and bushes and.
Yeah, the elevation of those can get critical though, because the rotating LiDAR, the field of vision of that's not very much, right?
Right.
So yeah, you got to have it right at the right elevation of whatever you want to detect. Again, getting back to the field of view and how big it should it be, and how detailed it should be.
Right. Well, I was hoping they can see tree trunks and stuff. As
long as they're not cut off too low.
Have you ever tried the LiDAR outside, Mike? Or
Oh no, I don't have one. No.
oh,
I haven't even tried these outside yet. So they're still in the baggie.
I tried the Nito LiDAR outside, and I found that its range was substantially reduced, but it did detect bushes. This is like, gosh, a long time ago, 2012 or so. So sure things are better these days, but it did, it had an effective, useful range of about 1.5 meters. It was enough to find a bush.
Well, it's not about finding the bush, it's about not running into it, right? As long as you have a range of sight that's longer than your braking system, then I've actually found that shortening it up is quite helpful, because something 6 feet away is not super important to me, right? Now you can make the argument to say, well, if you need to do, a slight correction, then it's better to do it sooner, right? But then you start getting into those false positives, like I was saying, because now you're reacting to everything. So I think I said I have a variable in my code where anything beyond this range is ignored, because I just don't care about it. I have plenty of time to react, say, and I think it's about 30 something inches, even on my outdoor robot. And that's why you see it almost stop. It doesn't really graciously avoid something and kind of smoothly go around it. It kind of comes up to it, stops, turns, and moves away. And that's why you see that behavior out of my robots, is because I've intentionally shortened that gap to eliminate the possibility of seeing something in the grass further down, especially like I was saying with the uneven terrain. If your robot's pointed down and your sensor's pointed at it, it's like, oh, I've got to stop and react to something. Whereas if you've shortened that down, then, that probability goes way down. But it seems like sensing objects is one of the more difficult things in robotics, no matter whether it's a can or a bush or, that's what we seem to spend most of our time doing, right? Whether we're, AI with a camera or a time of flight sensor or a sonar sensor, that seems to be the real challenge in robotics.
I'm hearing a step function, a step up in level of complexity for this year's Robo Columbus, and I hope that it doesn't backfire and nothing works. None of our systems work right.
Well, I made the decision a couple of weeks ago that I'm just going to stick with my camera again this year. I just got too far to go. Although I have changed my sensor array a little bit. I've mechanized it now where I have 2 sensors that are on a servo, so I can pivot them around. And they also can look up and down. So I'm hoping to give my robot a little bit of personality, hopefully. Yeah, it's like, oh, okay. So.
All right. I think we killed time of flight sensors.
There's my model.
Oh.
It's got.
Oh, cool.
And then the whole thing can go up and down.
And are those MaixSense sensors?
Yeah.
Oh, wow. And they've got a little screen on the back?
No. These
No,
are,
aren't those Benawakis or?
yeah, those are a different sensor.
Oh,
This is these Benawake.
Yeah, Benawaki, however you pronounce it. Yeah.
Benawaki.
I'm hoping to use a couple of those this time too.
They're really, I like them. I've seen no degradation in sunlight. And with the narrow cone, they don't false trigger a lot. They don't false trigger on, grass or clumps of stuff that I've seen yet.
They have a good rate of data too. So, you don't have to.
Well, no, you just set them up and then they just puke out a single reading.
Yeah, but I'm going to say it's every 20 milliseconds.
I don't remember what the frequency is, but yeah, it's plenty fast enough for sensors. Yeah, the only you can get them in UART or I2C, but I think one of the knocks I have against them is you can't change like an address. You can't have multiple devices on the same I2C bus that I know of. I don't know, Doug. Have you?
Well, the ones I got I've got the serial port ones because
that's what I've got too. But you've got to have a dedicated serial port to each one of them.
Yep, and that's why I'm using a TC4.
Yeah,
it's got 7 of them, so that's plenty. So you're right.
And you can just set them up to just say run, and they just spit out data as fast as they can collect it.
Right.
So yeah, they're super easy to use.
Yeah, I don't know if this makes a lot of sense because I may be looking at it very simplistically. But okay, so think of me, I have an array in front of me of 22 by 22, and the angle is pretty wide. I'm not sure the exact angle on this one, but I want to say it's over 40. So it's a pretty wide cone if you're looking at 25 by 25. So I was just kind of thinking to myself, like, well, if I pointed at a wall, all the readings are going to show up. So if I read and all of them are the same, I know I'm looking at a wall. If I'm looking at the vertical, looking at the columns, okay, if I'm looking at the columns and I have an isolated group of columns that are attached, but separate from the other readings, I'm looking at something that's either narrow, like a 2x4 or possibly a tree, so I'm going at. If all the trees are linearly different, then I know I'm coming up to a wall from an angle. If all the groups on the groups on one side angle, okay, yeah, and linear angle wall to one side. So I'm just looking at some of these more or less to test my hypotheses of what I'm seeing and whether or not it can go. If I see a random group of odd readings, like let's say 20% of the readings are different from infinity, okay? What I'm saying is I'm comparing them at a trip point. Then I'm probably looking at some low density obstacle. So anyway, that's what I'm looking at to try to prove if my thought pattern is correct.
Well,
so far I've got that if you pointed at a wall, they're all the same.
Well, actually, they're going to be slightly different. There's actually a translation equation because each one's going to be slightly angled, right? Of whatever division. Say if you have 8 by 8, and you have a 38-degree cone, you got to divide 38 degrees by 8, and each one's going to have a different angular
Good point. Good point.
direction, right? So
Yeah.
as you're pointing it to a flat wall, now if you're 2 feet from the wall, you're right, it's not going to be a lot of difference. But
Yeah.
the further you go, the more that's going to happen. And usually in the data sheet, they'll give you the translation equation based on the position of the sensor in the array.
Well, that's like on this sensor, you get too close and it defaults to a reading of 4. Okay. And so,
Too close.
so if you're really close, you have to consider that 4. But if you're at like 2 feet, before it is, you know, it's so small compared to the rest of it, you don't worry about it. But if you're coming up to something, you gotta know how you're coming up to it.
A lot of times you'll get along with a distance reading, you'll get a confidence reading out of it as well. And that's basically how accurate it thinks the reading is based on the difference of the wavelength of light.
Yeah.
Right? Because it's looking for a particular wavelength or frequency of light. And so basically, depending on how much of that it sees, it'll give you a confidence reading. And I know the ST series does that, Mike. I know the L1 we use does.
Yeah. Oh, yeah, they do.
The later series do the same thing.
Yeah, they do for each sensor.
I don't think, or at least I haven't seen whether in the packet that they transfer to you, I don't see that. There might be, there's a header.
The Benawaki ones?
Yeah. No,
I don't remember. I can't say off the top of my head whether they do or not either.
Yeah.
Right.
And I haven't really tested it against white versus black either to see if you know how big a reflectance issue there is. I guess that's something I should check.
But
yeah, I'm gonna have to, like I say, but right now I think it's good enough for me to use it as kind of a bumper. You know, I mean, I'm not trying to get anything more out of it than there's something up ahead. And maybe when I approach the cone, you know, it might give me a distance to that, but I should have that from other means. Because like I'm using the OD light, but I did not use, when I had it before, I wasn't using the depth camera portion of it. I didn't feel comfortable with it. But I did watch John's approach. He was going to use the depth camera, and he essentially took a glob of pixels and just had, you know, areas of interest all over his thing. So like he took whatever it was, I want to say 640 by 480 and broke it into 9 regions, you know. So that's one approach.
But I would collaborate with Scott about the like these 8x8 time of flight sensors. I did have to do some kind of a trigger amount, a sine or cosine function to straighten it out, because when I looked straight at a wall, it showed me a curve, and so I flattened it out by giving a little scale factor using a sine function.
Yeah.
Yeah, the Benawakis give a 16-bit strength value in the data that I'm looking at. So it's, you know, it kind of you could equate that to a confidence level. What's the strength of the reply kind of thing. So
yeah, but you got to kind of ask yourself on that one, Scott. Well, okay, I've got that. Now what am I going to do with it?
I use it to determine whether I'm going to update the value, because what I do is I keep a stored value, and then when I get new data, I look at the strength level, and
if it drops suddenly, yeah,
is it over a value, and the value is a software adjustable. So I can say, well, and I couldn't tell you, looking at the code I'm looking at, what it's set to. But yeah, so you can kind of qualify, okay, am I going to update it? Because I would rather use older data that I know is right than new data that I don't have confidence in. Especially when this thing's updating, multiple times a second. If I throw away one reading because I'm not sure about it, then it's usually not a problem. As long as you don't keep throwing them away.
Yeah.
But and as far as, the translation function to actually get a real distance out of it, I don't go to that kind of effort, because all I'm interested in is it closer than X, right? I don't care if I can determine whether the wall's flat or not flat, or I'm at some angle to the wall. All I'm using those sensors for is to keep from running into something. So if you look at it from that perspective, I've got some time to determine, is something closer or close enough that I need to react to.
Yep.
And of course, sometimes you don't want to react to it. And that's one of the tricks in the can is, you're telling the robot, well, don't run into anything unless it's a can. And then you can run into it. It'll be okay.
Yeah.
Well, does it feel like the energy is kind of dropping, and do we maybe want to call it?
Yeah, let's call it. But hey, before you go, what are you printing over there?
Hold on, Tom C's trying to talk, but he's muted.
Okay.
Okay, I'm unmuted now. I thought I'd just mention one thing in passing. I've been working at converting my RC pulse width modulation signals to serial data output. And that's all working now as of this evening. But one of the things that I did along the way was fire up my Saley clone 8-bit logic analyzer, which for years now I've run with the Saley logic application, the commercial one, which is a beautiful piece of software. It no longer works with my clone Saley box, which was quite a surprise. I spent a lot of time this morning trying to understand what's going on and trying half a dozen different versions of their Logic 1 and Logic 2 tools, which other people historically claim have worked, but it no longer works for my stuff. So that's point number one. If any of you have one of those and haven't used it for a while, you might want to try it out. So what I did was I've now moved to the Sigrok public domain data acquisition tool set, running the Pulseview graphical front end. The learning curve is really short, and I'm really getting to like it. So just thought I'd pass that on.
Yeah, I don't know. Logic, I've often wondered if they would ever just cut it off.
I think they've finally done that, yes.
Yeah, I know that the last time I used it, it was working fine.
Well, you can switch to Sigrok plus Pulseview, and it is marvelous. It is every bit as good, I would say.
Yeah. Yeah, I know that the open source one is supposed to be pretty good. The main thing you want is to make sure you have the protocol decoders.
Yeah.
That's what really makes them.
Yeah, and there's got to be about 100 of them
Yeah.
that come along with the package when I downloaded it this morning, and they're quite good. I've tried 4 or 5 of them. They're quite good. I had also mentioned that when I loaded this thing and installed it, the very first thing it did was it scanned my system to see what I had that it could talk to. So it not only found my Saley logic analyzer all by itself, it also found my my digital storage scope.
Cool.
And it knows how to talk to that too.
Well, that's great. So does that mean now your digital oscilloscope has now got a logic analyzer function?
Doug, that was my first question as well. I haven't tried that yet to see if it'll run them simultaneously, but that would be really slick if it could.
Yeah.
Because I do that all the time with both windows open.
I need to get a logic analyzer. I've been putting it off.
Oh, $8. $8 really well spent.
Okay. Yeah.
You can't beat the function per value of those little $8 modules. I mean, it just, in a lot of cases, if you're working with a microcontroller, it's better than an oscilloscope.
I'm going to share a quick picture with you, if I may. Let me just find it here. You should be able to see that now. That's just a screen capture from the logic analyzer I'm now using. It happens to be showing.
I just see your letter T.
Oh, you can only see the letter T?
Yeah, like your
Yeah,
name.
I can see a screen.
I see the screen.
Yeah, I see
Really?
it. Yeah.
You should see a screen with a bunch of logic analyzer horizontal lines on it.
Traces,
Yeah.
yeah.
I don't. Strange.
Okay, it's there somewhere.
Okay.
Anyway, this is a Pulseview. This happens to be showing the 6-character data stream coming out of the little 8-bit AT Tiny I'm using to do the conversion. And what you're looking at is the timing decoder and the UART decoder. Some of its functions are turned on, some are not. It's really, really good. It's every bit as good as the Saley product from what I'm doing here.
They would do that too, though. So, they're about the same.
Yep. And this one's legitimately free.
Yeah.
Wonder why I can't see. All right.
Do you have somebody else pinned or something?
No. I just.
Hey, Mike, go
Yeah.
into your the change layout and hit highlight. I think it's called spotlight.
Yeah, because I just saw a big T was like his name for the when he doesn't have a video turned on. So
I'll just put it up again and see if it looks any different.
Yeah, take a look. Go into you should see it. It works.
Looks the same.
I've seen it with no problem.
it's just a bigger screen with a T on it. Okay.
Oh
Maybe
no,
next.
he blocked me.
Okay, that's cool. Well, I'm
nice
sad to hear that, Tom.
Yeah.
Yeah, I mean, I don't think they lost anything on that because that part is, pretty old.
Well, if I ever needed, from a commercial point of view, I needed a better logic analyzer, they would be the first company I looked at. I know they're expensive, but boy, are they ever good.
Yeah. We had a member who works for the people who make garage door openers. His name was Richard, and he was he actually had the 40-pin jobber, so he spent some jack on that, getting the official one. But they are like metal cased, really, really cool. They come with leads that don't break every time you use them. It's just a lot of nice things to them.
Yeah.
So Tom, did you actually show your unit?
Pardon me?
What does it look like? Is it a little box with small probes on one end and USB on the other?
Let me just unhook it here.
Yeah, you've seen these, Ray. These are the little.
We can put the link to it since I'm looking for one. Yeah.
It's
just go to Amazon and say Logic Analyzer, and you should
see any of them. Okay.
Yeah. Now, okay, you have an option. Sometimes you can get them with Tom. Show them the little probe dingles. You can get those. Not very high quality, but sometimes they come in handy.
Oh yeah.
Most of them just come with DuPont cables.
Yeah, you want to get the little hooks if you can.
Yes, and you'll probably pay about $2 more for those.
They're worth it. $2.
Yeah.
Just you have to position everything carefully to make sure they stay on.
Yeah, and you also have to resolder them every 2 or 3 times you use them, but it's a different issue.
I liked it so much I bought a second one just because if I broke it, I'd be lost.
Yeah.
And for $8, who cares?
Yeah, I think I've got 2 or 3 now. Yeah, because
Yeah,
of,
those are the little
yeah,
hooks. I
I
think.
yeah.
I
They're just
bought
really-
one of the 16 channel units that has to be, you have to kind of assemble it. Yeah, you get the basic circuit board and the software, and then you got to put the bits and pieces together and stick it in a case. But I got to admit, I've never found a reason to want to try to hook up more than 8. So
Yeah. I usually I'm hooking 3 or 4 at the most.
if I have to hook up 8, I probably don't understand the problem very well.
Right.
So additional protocols, would that be like, UART, I2C,
SPI? All of those. And there's variations of those too that you have to take into account, and that you can set the settings. But I use them a lot for I2C because that way you can look at the actual signal and make sure all your sensors are communicating the way you expected them to. Or if not, what's going on?
Check this off. I'm somewhere here. I have the window. Let's see why I can't see it in the set of windows here. And I'll show you the window, the live window, and then you can see what the encoder functions are. Where is it? There, session 1, Pulseview. I'll share that. What you're seeing, if you can see that now, what you're looking at on the right-hand side of the window is the set of encoders. I've opened most of them up, not all of them, but there's a lot of them in there. And a lot of them are device specific. So see if I can find one that means something to this group. JTAG communications. There's a decoder for that.
I2S is an audio.
Pardon?
A lot of times
is an
those
audio.
analyzers will actually output JTAG data.
Huh.
Some of those interfaces may be an interface to output data, depending on the hardware.
Mm-hmm.
Yeah. Anyway,
So
there's a lot more here than there were in the version of Logic I was using from Saley.
Logic, I don't know if they might have had some add-ons you could add on.
Yeah.
There were all of the ones that I was interested in were in Logic.
This little window here in the bottom right corner, I've just played with it a little bit. This is the window where you can access the collected data set as spreadsheets in various forms, tabulation forms. This thing also has math. You can perform math on rows of data that you have collected and produce additional rows, just like with a scope. So haven't done any of that yet. I just started using it this morning.
And which Logic probe are you using?
The Logic probe I have hooked up is a cheap Saley 8-bit logic analyzer, a clone.
Is that SAELIG? That's Saley?
SALEAE is the brand name. And if you go out to AliExpress, you will find dozens upon dozens of vendors selling variations, the same thing with different labels on them. And I picked $8 for a price. That's probably the right ballpark to buy one. There are dozens and dozens of them, and they are 8 bits. There are also 16-bit versions. There are also a lot of other aftermarket designs of logic analyzers that are not called Saley, but they tend to get a little pricier because somebody's got to pay for the development work they did. But almost all of them run with the same Sigrok Pulseview public domain software package. I don't know if you're familiar with Sigrok. They support hundreds of hardware instrument type devices on computers, hundreds of them.
Is that SIGROCK?
SIGROK. Just Google Sigrok. and it's a public domain thing, a GNU thing, whatever you want to call it. When you find it, you'll know you found it. It's really, really impressive.
I see it. Thank you.
Yep. I've tinkered with it a little bit years ago when I first ran across it, but I was happy with Logic. I didn't have any reason to change, so I didn't bother. Sigrok just keeps getting better and better. It wasn't this good when I first looked at it.
That's cool.
So I can really recommend it. I mean, based on 1 day of intensive work, I've been at this most of today, troubleshooting the software design issues and a few other bits and pieces with my cobbled together encoder. But without a logic analyzer, I would not have solved these problems. It's that simple. Or I wouldn't have solved them today. I might have been working on them all week with a scope. But I'm working with a DigiSpark. And of course, the problem with a DigiSpark is you have no console. So it's like troubleshooting naked hardware. Okay. Any other questions?
Now, I was wondering, how necessary is this little $12 device if you already have an oscilloscope? Like, for instance, I have the DHO 804 oscilloscope. If I already have that, is it really necessary to get this other device?
I don't know what an 804 is.
Actually, let me see if I can show it. So it's one of the newer models. Came out in 2023. I think it's a direct upgrade to the Rigol 1054Z.
Oh, you have a Rigol. Oh, congratulations. I would love to have a Rigol.
But yeah, so
does it have a logic analyzer built in along with the scope?
It does.
Then you do not need one of these. You have way better stuff already.
Okay. Good to hear.
Yeah. Kyle, so if I need a logic analyzer, I'm coming to you.
Okay.
Yeah, that's a really nice box there, Kyle.
Thank you.
Thanks for showing it to us.
Mm-hmm. Yeah, so it has been collecting a little bit of dust, just because like I don't have the most experience with using oscilloscopes. So like, do you have any like specific advice on like where to go to that has like a nice enough learning curve so that I can still like catch on, but it's not and like learn a lot, but not too steep where I like get completely lost? Like any sources for learning?
I would suggest that learning how to use an oscilloscope or a logic analyzer in practice becomes an iterative hands-on thing. In other words, build something, right? Learn how to build some pieces of hardware, maybe with or without software, and then start hooking up your scope to it and look around. Even if there's nothing wrong with it, hook up the scope and look around. And by hooking the scope up and trying to see the signals that, for example, the construction article that you may have used to build the device may have shown you what some of the signals should look like. Even though it's working, hook your scope up and see if you can see those same signals. And once you get to that point and you say, shit, how come I can't see them? Now you've got a goal for your learning, that little piece of learning. That'll be far more effective.
Yeah, I would say, like if you're looking like at 10 megahertz, 20 megahertz signals, a single ground for all of your channels, all your probes will work. But if you're like 100 or 200 megahertz, then things have to be grounded really well.
You'll eventually get there, yeah, but you're probably not worried about 200 megahertz signals yet.
Right, right.
You want to make sure you're not doing something like trying to measure things that could potentially be floating. Because when you attach a ground on the scope, it attaches a ground. So where would you run into
the equipment ground or the third phone?
the most common when you would run it under our little robots is if you were trying to measure the voltage across an H bridge output.
Or across the motor, yeah.
Yeah, that's
Yeah.
floating. That's not grounded. So as soon as you put a probe on it with a ground, something's going to go. Something will blow. So you know, there are some use cases that you have to be careful.
Probably a scope that nice has differential inputs though.
Huh? I'm sorry.
Probably a scope that nice has differential inputs on like channel 1 and 2.
Yeah, that's what I'm saying. That's what you have to learn, but that's a different level of learning. You know, that's you don't necessarily get there.
Doug's making a good point, and that is you have to understand where to hook up the ground. You probably don't want to hook the ground up to one side of the motor. You want to hook it up to the
power supply,
your logic system.
The
ground of your power supply, not the ground of your motor.
Yeah.
Well, no, that can work against you if you're not careful. I'm just saying is you got to be careful not, like Tom said. So you got two leads, one's a ground and one's the probe. Oh boy, here's a motor. I want to measure across the motor. Wrong, bad. Wrong.
Doug's making a good point. A scope gets treated a little differently than a multimeter.
Yeah.
In terms of where you can hook it up.
That's right, because a multimeter is essentially floating.
Yes.
Yeah.
Now the interesting thing is his Rigol may be floating too.
No, I got.
It may not be just.
I have the 4-channel, the older Rigol, and I can tell you that there is differential inputs that you can do, but you got to go do it. You know. And so in that case, you would actually
Kyle, we can give to you.
And no ground.
So getting back to Kyle's original question, how do you gain this knowledge?
I was just looking for the beginner's oscilloscope handbook I had here. It's not here anymore.
So I imagine Rygold's got a pretty good user manual, probably online, that you could look at.
Yeah. If Kyle has a logic analyzer function in, would it have an extra connector with like 8 pins or 9 pins on it, 8 signal channels and a ground, in addition to the 2 or 4 analog channels?
Well,
it probably does.
If I'm, to be quite honest, sometimes I'll use if I'm just working with a microprocessor, I'll use the analyzer instead of the oscilloscope, because it's easier to, quicker and faster to get it on. But
you guys advised Kyle that he already has something better than these.
Right, he does.
Logic analyzers.
Yeah.
And I'm just trying to understand, because I've got a regular old Rigol scope, but it doesn't have a logic analyzer in. And
neither is mine.
And so I'm curious as to whether having a logic analyzer built in means that you have an extra connector with a lead that comes out of it and 8 wires hanging off of it.
Yeah, I think he does. Yeah, I think there's a little thing that you plug in that has the different leads that you can.
So Kyle, do you have a logic analyzer input connector on your scope?
I'm not sure. So this is the whole scope right here. Is it like a probe? So there's the 4 channels, the ground. I'm not certain what this.
That's the test. That's where you test the signal.
Right.
And
I don't see a logic analyzer. I would expect to see like a 9-pin header that you plug some kind of like cable going to a dongle.
Something in the back. Take a look at the back.
Could be in the back, yeah.
The back, from what I see, just has USB, HDMI, USB, and a LAN cable. You said a 9-pin?
Well, it would usually, it might not have the ground. Might not have the ground, but it would have the 8 pins.
See, I don't think he's got a logic analyzer. I don't see logic analyzer input
Okay, Kyle, flip it around. I want to say that on that model, in the logic analyzer goes in that little, pull it up. See that blank between the first channel and the USB? Usually that's where the logic analyzer.
You mean somewhere around here?
Yeah, it's a module that fits in there, I believe. That's just like a knockout plate.
No,
What is
I
the
think
model of that scope, Kyle?
Yeah.
it's the DH DHO 804.
No, I'm looking at the data sheet. It does not have logic analyzer input.
Oh,
Okay, so spend your $8 and get a logic analyzer.
Yeah.
Yeah, I put the cheapest one that was on Amazon. It was $750. Yeah, that's not with the nice little proby things. I think you have to end up playing about 11 or 12 with those.
That's great. I'm going to get one of them.
yeah. No, I found one on AliExpress for like $4.24. So no, I'm guessing that there's a lot of people who drop ship cheap stuff from AliExpress and put it onto Amazon at a higher price. So
yes, I agree. Is there any shipping on that AliExpress?
free shipping over $10.
Oh,
Buy
okay.
two of them.
One of their small units. Yeah, that's fine because you're not in a rush. It's not like you want it tomorrow,
Right.
So
Yeah, Kyle, I think
I buy things from AliExpress all the time.
the key distinction here between what you'd use your oscilloscope for and what you'd use the logic analyzer for is the oscilloscope reports the voltage as it varies over time. And that's all it reports. Okay, you can subtract one channel from another, but it's basically voltage as it varies over time. And the logic analyzer takes digital signals and interprets them. For example, a serial string which goes 10111001 turns it into ASCII, interprets it as ASCII, or it interprets it as data, which is a higher level of meaning to extract from a periodic signal than you can get from from just a time varying voltage.
Right.
Yeah,
And
most of the digital storage scopes.
either because it's got a real big depth. Okay, so once you trigger it, you get a whole 2,000 readings or something, and that's, I don't remember exactly how many, but a boogoos. And then you can slide back and forth on it and look for patterns. Where on a scope, if you're looking for a reoccurring signal, you have to sync it. Okay, so
Well, don't most digital scopes
really, but what a scope can do is it can show you the true rise time. It can show you ringing noise and things like that.
Both.
Yeah, but don't most digital scopes these days have decoders on them for most all that I2C, SPI, all that noise anyway?
Only if they've got a logic analyzer built in.
Yeah. My Rigol doesn't.
I mean, I've got one right now. It's $400, and I've got 4 channels, and I can decode I2C. It's a SIGLIT. I can decode.
Oh,
I2C,
you're right.
all that kind of stuff.
Harold. I haven't used that. I mean, I haven't used that in a long time. You're right. It does have that feature.
Yeah, and
you're right.
And I think it's all wonderful and good. In fact, I can tell you, I can count on one hand the number of times I've actually used it since I got it. But I got all the capabilities.
Yeah, you're right. That's I remember when you cracked it and did the upgrade to 100 megahertz, you got that part.
Yeah.
Yeah. So.
Yeah, that kind of thing. It's fun stuff. I don't know. I just glanced, Kyle, at your. I don't know what. I jumped in late to this conversation. I don't know what kind of scope you have over there, but
it's a Rigol DHO 804.
I'd be very surprised if that thing doesn't have some kind of capability there to decode I2C and SPI, if that's what you're looking to do.
But I would say that,
yeah.
And Harold, I'd say this too, These $8 jobbers are so easy to use with the
Yeah,
software.
I will tell you, I did an $8 jobber. I never did get it to work, and I'm sure it's one of these ID10T errors, you know, on there that that stopped it from working. But I've got it sitting right over here. I almost could pick it up, but I need to look at it again.
Yeah.
Using all the stuff, I got confused. I got upset. Kicked it to the curb and went on to do something else that didn't blow up. So
Kyle had asked a question about the advantages of using the logic analyzer if he has a scope. Kyle, I ran into exactly that scenario earlier today when I was attempting to solve one of the problems with my encoder that I'm working on. I'm going to share my screen again, if I may, because it'll illustrate the point I want to make. What you're seeing here is the traces for the working device. The top line is the serial data output. It's UART data at 56 or 57,600 kilobaud. So it's quite fast, but it didn't work at first. And looking at the logic analyzer, it just looked like a mess. So when I put it on the scope, when I say it looked like a mess, it just, the binary patterns weren't consistent with what it ought to look like as a digital UART signal. But when I put this same signal on one channel of my scope, it became immediately clear what was wrong, because then I could see the analog voltages associated with these digital signals. And that's when I discovered that the person who wrote the code I'm using, a third-party person who wrote this very fast software UART, had elected to turn off the pull-ups in the digital output pin that this thing drives. And as a result, there was no pull-up. He just assumed everybody had pull-ups on their outputs. And I added one and I solved the problem. But I wouldn't have solved it until I not only looked at the digital logic output, but also looked at what it looked like on the scope. So that's a very worthwhile sort of example. Sometimes the simplest look at what the waveform looks like will help you understand why the digital logic isn't working correctly. Especially as your devices go faster and faster, and you can't look at them with a multimeter and an LED anymore.
Yeah.
Thought I'd mention that. Had that problem today, and both devices were in use.
Mhm. I'll just buy it.
Yeah, buy one for $8 or whatever it is. Buy two.
yep, if it's from China, buy two. Buy two, you got one. So, you know, you got one, you got none. If you got two, you got one. The whole spare thing. You got to come up with $10 anyway to get the free shipping. So.
Save the shipping. Yeah.
Yeah.
Okay, on your scope, do you have, like, between the channel 1 button and the channel 2 button, there might be a button that says add, like add channel 1 to channel 2?
You're talking to Kyle?
Yeah.
Sorry.
Not sure it's there, Ray. I think it's up in the menus.
Oh, it is? Okay. Yeah.
Yeah, they have a lot of, in Wrangles, they have like menus on each side, and they change on whatever menu button you're pushing. So I'm thinking that's where they hide that, but I don't know.
Oh, they do. Okay.
Yeah.
Yeah, I have an old tube scope, so
yeah,
I have a button for add and then channel 2 invert. So
yeah, I would say that Tom has the best idea. I remember Wrangle having a pretty good menu. It's a little deep, but you know, you can, if you wade through some of it, you can kind of get the idea to get started at least.
Yep.
And if you stay with like just microprocessor projects that are only going to be 5 volts or less, you know, it doesn't, you can, that's a good safe circuit that you can, you know, where everything goes to a ground. That's great. You know, you can play with either one of these tools and learn a lot.
Kyle, have you used your Rigel scope on anything yet?
Not any big projects. So I have like tested like 1 or 2 channels, like hooking it to to the test terminal right above the ground one.
Okay.
And that one worked fine. What else did I do?
Here's a suggestion. Do you have a 555 timer chip at home?
Recently I have, yes.
Well, hook one up. Like you can easily look up the various circuits to turn them into an oscillator. So put a 555 oscillator together. Takes about 3 parts in about 5 minutes, and hook it up to your scope. You'll learn an enormous amount just from that simple experiment. And there's nothing at risk, right? It's not like you've got a $100 part you might burn out if you touch the wrong pin.
Right.
You won't burn out a 555.
Yeah, don't those work up to like 12 volts or something insanely high voltage?
Who cares?
I think 15.
Yeah. Nonetheless, it's an ideal device to hook up because it's easy to understand, and now you can look at it on the scope. And you can look at the sawtooths, you can look at the RC time constant curves, you can look at the digital output, you can look at what happens when you vary the threshold voltages. You can see all that on your scope. See what happens when you run it when you change the components and you end up running it at a higher frequency or a lower frequency. Scope will tell you all of that.
Sounds like a good idea, and I will certainly try that. Aside from that, like either for like Arduinos, Raspberry Pi, Picos, or Teensies, of that matter, what are oscilloscopes like really good for there? Like I know they can measure like the voltage drop of capacitors over time, but what else?
Well, I can tell you the state of your pins. So, you could just hook up an Arduino and say, take one of the digital outputs and probably you would, and just go ahead and tell it to like run it every 5 milliseconds, change state, and you can watch that. I mean, you can get a lot of information off of it. In use, like I say, a lot of times what you're doing is you're using it, looking at the protocols, or you're looking at some of the sensors. A good example is I had a sensor that was had an encoder on it, and it wasn't getting good encoding. Well, I took a look at the 2 channels, and I was able to see that the quadrature, the part wasn't correct. So I had to adjust the sensors to get that up to 90 degrees so that everything would be cool. And what is that? What you got?
Well, that's if a wrangle took a poop. This is what would come out here. This is a little baby scope.
A baby scope. Oh, okay.
I have one of those.
1 channel, I think maybe a megahertz bandwidth. So, that's your test probe right there.
So, song, baby scope, baby scope.
I got one because it runs off a 9-volt battery and I can use it outside.
Yep. This has its own battery in it. You can charge the battery. It's got different modes. You can, increase where the trace lines sit and everything else. So, but only 1 channel. So
I was amazed at how good it was when I put it together. Considering I paid about $15 for it, it was pretty amazing.
Yep.
Nonetheless, my Handtech DSO, which is an entry-level Handtech, was only $85. So that was the best $85 I ever spent on a scope.
Yep.
And I spent a lot of money on scopes over the years.
So you mentioned,
I have 2 boat anchors, 2 tube scopes that haven't died yet. So
I finally made several years ago, Ray. I just couldn't take the space on the work bench any longer, and I just said, "Screw it," at a wrangle, and never looked back. I was so glad to see those go out with the trash. It was worth it.
Oh, you trashed them. You should have taken them to the makerspace. Somebody.
I think I did, but you know what I mean. That's the trash.
I
So-
found out mine were vintage scopes and they were worth a lot of money.
Yeah.
Collectors bought them from me.
I had an old a Dumont.
Yeah, me too.
Long time.
Dumont. I never even heard of those.
You know, that was like, I think it was one of the first commercial scopes. You know, they didn't have fancy things like grids on the front of it. You see them in old sci-fi movies, you know, where they'll have a pattern going on them.
They were designed so you could troubleshoot television sets, black and white TV sets.
Yeah.
That's where I got mine, from a TV repair guy who was replacing it with a better one, and he gave me his old one.
Yeah.
Man.
You know, those tube scopes do a very interesting trick that the digital scopes these days can't do. There's a couple of cats out of Germany that kind of make them harder. I remember seeing them on Smarter Every Day a couple of years ago, and they play waveforms into them attached to their oscilloscopes, and they actually make animations on those tube scopes because of persistence of vision and all that kind of stuff. And they do some pretty cool things. Our digital scopes these days are not going to do that because they just don't operate that way.
No.
You know? It's pretty cool though.
Yeah.
Okay, in the Wayback department, have you guys ever used an analog storage scope?
Oh, God.
Yeah.
Yeah.
Yeah, it had like the phosphor had persistence and
Yeah.
you would trace it once and
Blow up.
Can't
green
see it. I
and
can't
sort of
see it.
fade
Oh
away.
my God, it's all white. Yeah.
Sorry, that was off topic, but
Yeah. Yeah.
yep.
You
Okay.
remember when computer memories were little tiny toroidal cores with matrices of wires through them? When I was in high school, I worked for a researcher at the university who was adding toroidal core memory to a television set, so it would remember what it saw.
Damn.
I used to work on mini computers, and we had two mini computers side by side. So you'd load up a diagnostic into one, then pull the core memory board out, push it into the other one, and run it on the one that was broken.
When I was in university, myself and a friend of mine bought an old UNIVAC tube computer from the engineering department. They were scrapping it. $50 it cost us. It came with 3 huge cardboard boxes full of spare tubes because it had a mean time to failure of tubes of about 45 minutes. It had a rotating drum memory. That was its main memory. A whole 1 megabit worth of rotating drum memory.
That's old school.
Yeah. His dad was a commercial electrician. So he had a big shop, so we could get the 230 volts at 30 amps we needed just to warm it up.
Okay, I think we're degrading into old geezer memories now.
I wish I had
Maybe it is time we wrapped it up.
So a quick observation before we go. I've been working on my trying to do speech recognition, and I won't bore you with the stuff I've been doing there because the success rate is at 0 right now. But in the process of doing that, I was creating or flashing my new Raspberry Pis, and the new bookworm version of the Raspberry software requires you to use virtual environments. I did not know that until I started this test.
Is the Mickey Mouse too much to ask? No, it's not. Yes, Mickey Mouse, please.
I'm going to mute
Harold.
Harold. Can you say that again? You got
A new bookworm version of the Raspberry software requires you to use virtual environments. It's no longer a recommendation. It requires.
Really?
You can't install anything. You can't pip install to the root stuff. You have to pip install to a remote environment or whatever virtual environment.
Really?
Yeah. So I went back to a prior version. I wasn't ready to play with that yet.
So
I know
when,
it's a
when did this
recommendation.
happen? When did this happen?
Well, I've got this one. I can't lift it up right now. Last week, the week before, I've been playing with it the last couple of weeks. So, though I've gotten sidetracked on some of my other stuff, but I bought me a new Raspberry Pi 5 and a Raspberry Pi 4, and I wasn't really ready to play with the 5 yet because I heard it had some difficulties. It is faster, and I've been trying to do that AI stuff that you hear so much about, and you can apparently run one of those AI things on a Raspberry Pi. It's very slow, but it works. I actually had that work, and actually did not have that work. It was on my Windows I had that work. But anyway, in the process of trying to get the Raspberry Pi to do speech recognition, because there's like 1,000 examples of how to do that, and it takes 10 lines of code. And so far, it has never worked for me. And the first things I ran up against was I couldn't even pip install the speech recognition code because it wasn't in a virtual environment when I was in the bookworm version. I had to go back to the prior version in order to get that part to work. And then I got to pass that you couldn't load it, and then later on it wouldn't operate the way it's supposed to. But I haven't got past that yet. I won't bore you with all the details because I don't understand them all myself.
I saw that. I believe that virtual version is a virtual Python version from like a Python version manager. It's not really when you say virtual host or something. A lot of times that means you got a whole different hosted thing, and you got a VM going on for another compute device. But I believe what they're talking about in this case is they're doing it so that you can have several hundred different kinds of Python if you want installed in your box, and depending upon which you choose, that's the one you'll currently be using. And so that pip install thing won't install on because they want you to be like the node version manager kind of thing, allow you, because what happens is you get into version hell of
Right.
what thing works in what deal. And so I think that's what they're talking about in virtual stuff. I don't think it's actually has anything to do with the operating system per se, but I think it's got to do with the way Python is installed on that. Is they want you to do it in a virtual version manager type style. And I wish I could be more succinct with that, but I believe that's what that's talking about.
Yeah.
And it's a great idea. It's a great idea, by the way.
Yeah, I agree too.
I may have missaid exactly what I was getting at. There's something called VNVM, which creates a virtual spot on your virtual folder that is sort of like a Docker. You create a little virtual thing there. You get inside there by activating it, and then you can pip install there. You can't pip install in root.
Yeah,
Yeah, that's what I was going to say.
after you get used
should
to
be
it,
able to
you'll
install
love it.
inside the environment.
Oh, I
Because-
think you're right. I think if I got used to it, I would like it because it's recommended for very good reasons. It's just I was trying to get the darn speech recognition example to work without having to learn how to use the virtual environment first.
Well,
And
even
I
worse,
decided I'm going to have to learn that.
you don't want to have Python pooping all over your system and screwing every Python project that you have.
Well, see, I understand that, but I use each Pi I use for one thing. I don't have multiple projects on it. That Pi is for this particular robot. It's only got the one project on it. So I'm never going to come up against that problem. So I didn't want to have to deal with the complexity.
Okay. Well, I use I think it's VNV, and I love it. You know,
Yeah.
the biggest time I get in trouble is when I try to do something new and forget to create a virtual environment. So if now they're requiring you to do that, that would be great.
Yeah,
So
that's the
Doug,
new
you should
bookworm
be able
version.
to deal with that by putting a virtual environment selector statement in your .bash RC. So whenever you log into your RPi, it selects whatever your favorite virtual environment you're working with.
Yeah, there's ways to make it easier, and I understand that. I just didn't. I was trying to get the darn example to work just to see if it would work, and I was getting in trouble with that. So I went back to the prior version so I could get past that particular problem, thinking, okay, eventually I'll follow Doug P's idea and actually learn how to use the virtual environments, because that's going forward, going to have to do it. Might as well get to it.
Yeah.
But
Well,
first,
on
I
that-
just wanted to be able to speak to the darn computer and have it speak back, like these 3,000 examples on the web showed me how to do.
Well, on that, as a follow-on question for you guys, that because I'm in a similar state of newbiness with virtual environments. I don't like them, and I haven't really had to mess with them. But how do you guys handle having multiple environments that you use for different projects? Like, do you have like a naming convention, or do you use one most of the time and have an odd one for this or that didn't work? Or
Well, every time you start something new, you should have a new virtual environment. Okay. And think of a virtual environment as, okay, you got like some sort of core Python files that are on the machine that are always there. Okay. When you got your machine, there's Python, right? Python was on it. The problem you run into is that's stored in one location. And then there's another location that you store packages that you put in. So then now you have two locations. And depending on how they interact, you'll find that, like Harold said, you'll be in version hell. So the right thing to do is just create a virtual environment. You put all the dependencies for that project in that virtual environment. Now that should be like you're just working with those files. So like if you get out to step 672 of the instructions you're following and it doesn't work, you just boop, blow it away, and all those packages that you installed aren't pooping all over your machine. Okay. So it's just, it's just a much cleaner, easier way to do it. And you can have as many virtual environments. And all they carry, Paul, is that everything that's in the virtual environment is basically all of the dependencies for that project. Okay. So you have some sort of core Python that's on the machine that's not virtual. So like when you write Python, it starts. Okay. But if you're in a virtual environment, that's not the only, you get all of the packages that you've installed in the virtual environment. Okay, so now it keeps it clean. You go to a new project which has, instead of version 6.4723, that's for version 2. Well, now you're not going to have that virtual environment interacting with the original one that you got working. So it's just a much smarter thing to do. It's a Python thing. I mean, Python is constantly changing all the time. And so things that work today, there's no guarantee they'll work tomorrow. So
what, like, for example, to Harold's point, the being in version hell, I think it was when Python was at version 2.7, OpenCV, which is based on Python, was at version 2. OpenCV went to version 3, and then Python went to, I don't know why they skipped so many, but I think it went from 2.7 to like 3.4. So there were a lot of bad things that happened between those versions or something. Anyway, the OpenCV definitely worked with the older version of Python, but there were a lot of things that broke when you went to the newer version of Python, version 3.4. So the virtual environment, basically you could stick the older version of Python 2.7 with the newer version of OpenCV, and that would kind of freeze that. If you, then you get away from the thing, and even Arduino will do that. They say, oh, you have libraries you can upgrade. Well, not all those libraries are keeping pace with updates from other libraries. So like on the ESP32, they actually had to go back to, I forget which version it was, 2.18 or something, because the later versions wouldn't work with certain boards. So that kind of, it protects you against that situation where, you know, it says, you can do updates and it won't affect your virtual environment at all. It won't change, you know, how that was set up with whatever version of, like, for example, Python and OpenCV and
That's
whatever else, you know, you happen to use at that time. That actually worked.
yeah, that's the primary reason Zemo, my rover over here, has been sitting on a shelf, because of what I wanted to do and what I needed to do. Needs like 3 or 4 different versions of Python running in various Docker things and doing stuff, and it just got too much. And so I'm like, we got to do something different. And I kind of bolted on all of that, and I hadn't got back to it. I'm sorry, Zemo. Sorry. I know. I still love you. There you go.
Doug, did you say you had the Raspberry Pi AI kit?
No, I do not. I looked at that. I was thinking about buying it, but it looks like it's pretty much focused to vision AI, and I'm interested in text speech AI, sort of like Chat GPT-4, that kind of stuff.
Did you actually see one?
I saw one advertised just the other day on my email feed, or maybe it was the news feed.
I'll have to look. They've been out, you know, all of them have announced it, but nobody has stock, and I was wondering.
Yeah, it might have just been an example of how to use it, and they weren't saying there was available.
Okay, all right.
I've looked at 300 plus AI advertisements and articles lately trying to do what I wanted to do, and you know, I looked at that one real quick. I saw vision only and said, heck with that. I'm trying to do something else here.
Yeah. Cool.
Yeah, it kind of makes me want to ask what, you know, okay, Dockers seem to do similar things that a virtual environment would do. Are there other things that a Docker can do that a virtual environment can't do?
Docker, according to what I've heard, and Harold can tell this a lot better because he's much more of an expert than me, but the point of Docker is that you can set up a virtual environment in your dock, and then you can publish that to other people, and they can just download it and use it. Yeah, like you give away the virtual environment, all the setup in the code, and they can just run it. It's a portability thing.
Yeah, I mean, for example, in my day-to-day work, we needed a very specific version of Chrome running to do some CSS, some headless thing to get it, and to print out some these. Oh man, I'm so tired. We needed a very specific version of Chrome running so that we could use it in a headless form, because we use that as a PDF output. So we'd throw it on an HTML page, tell it to print PDF, and we get a PDF out of it without anybody even seeing a browser. And we had it working really well, and it was working great right until Microsoft updated all the Linux containers, and it went away. So what we did was we went and built a whole Docker container that now the client's using with a specific form version of Chrome we know works. And then we uploaded that into the cloud. So as many of those copies we have to have or need to have are now laying out there. And so if somebody like Paul, you wanted to run that version of Chrome on the thing, well, here's a Docker container. Go fire it up on your box. There's an endpoint you go hit with the information, and you get a PDF back. So those are the sort of things you do with the Dockers. And it's a very small. It can be very small because it's using a lot of stuff from the host and some other things to make it more efficient. So you're not loading a full Linux operating system into it, but you're loading just enough to run all the stuff you need to run and communicate with the host to do all the hardware sort of things like access hard drives and that kind of stuff. But it's running in its own process, and it's totally contained within itself. to do what it needs to do. It doesn't know how to do a whole lot. Like for the most part, in Docker containers, you might get a shell on them, you might not, depending on how they're configured. Although they are capable of having shells and doing things, it's literally its own little OS, and you get to have that bucket shared around, and other people can run it without having anything else on their computer other than the Docker runtime to be able to launch the machine, launch the Docker machine, and then they get those capabilities. Does that make sense, or did I go too far on the thing?
Nope.
Yeah. Okay.
Makes sense.
Basically, I think the Docker file examines, do you have the requirements that it wants? And if you don't, it automatically loads them for you within your little virtual doc thing.
Yep, it'll load all those sorts of things as you go. When you go build the Docker file, then you got an image and you run the image and away you go. Yeah, it's really cool actually.
Yeah, I think a way to think about it is that these different kinds of virtualizations virtualize at different levels. So a virtual machine virtualizes just barely above the hardware level. You have the hypervisor that sort of like is so minimal, but you've got the whole operating system is virtualized. The Docker virtualizes above the syscall level. So the kernel is the same for everybody, but the syscall and above is virtualized. And Python virtual environments virtualize above the base Python package. So you add different, you modify the different aggregations as you guys were saying. But you can kind of think about it similar as being another point on a spectrum of virtualization that ranges from down the bottom in virtual machines where you're almost virtualizing the hardware up to the OS syscall level, up to the Python package group level.
So always something.
Always something. Yeah.
Keeps
Yeah.
you young. Or
Unfortunately, that discussion didn't help me with my problem, which seems to be related, where ROS 2 on my laptop, it will run natively, it seems, on the laptop, except if I try and run the TurtleBot simulator, when it throws a version error related to there's a Python data analysis package that whose name I just forget. It's like really ubiquitous. I don't remember. Anyway, it's like, okay, it mostly works, but
Yeah, you've done the sudo update, sudo upgrade, all that stuff already.
I've done all of that, and can't get TurtleBot simulator to run because of I will tell you why. Well, what do you know? It's working.
you're welcome.
Yeah, because we're all here watching.
Unbelievable. Unbelievable.
Inconceivable.
Inconceivable. Unbelievable.
See, that's the power of positive thought right there.
You guys are brilliant. You fixed my computer and I didn't even know it.
My speech recognition is still not working.
Oh, sorry, Doug.
Maybe next week. Although I've gotten so many little project running right now. I don't know if I'll get back to it in this week. Too many hobbies, not enough time. Boy, I'm glad I'm not working for a living.
Well, this is great.
I'm going to let you guys go. I've got something else that's coming up back in the back room or the other room. Been fun. Have a good time.
Bye, Doug.
See you, Doug. Thanks for stopping in.
Bye. Yeah. I guess it's time to hang up and go.
I think we've actually covered quite a lot of ground today.
Yeah.
Whole variety of subjects.
It was a good chat.
So,
All
see you
right,
guys
bye.
later.
Good night.
Bye.
Right.